Hi, welcome to this Open Security Summit session in February 2023. And we're going to have a really cool one now, which is about live threat modeling of a food ordering system by Lewis, one of our threat modeling experts in the planet. So over to you, man.
Thank you very much. I hope I'm good to hear. I hope my microphone is not too muted.
Yeah, all good.
If there were any problems with my audio, please let me know. Raise your hands, not to keep me talking. I hope I don't have troubles like I did once with my ISP dropping my call and having to log in with my phone and showing screens of the screenshots of the screen. That was really stressful at that time, at that OSS summit of last year, but it was fun. So let's dive right into it. So who am I? I am Lewis. I'm a cybersecurity architect. I have been doing threat modeling for over a decade now. I started early in the 2010s, and I have looked at many interesting systems. I was a consultant working for a airplane company in Europe, analyzing some of their systems, looking for threats and doing risk analysis. I have done IT, OT, automotive systems, IoT systems, pretty much. I mean, I think I'm only missing like medical devices, and then I would be complete in my expertise. And one thing that struck me while working on these different systems is very often you're frozen when you want to start threat modeling. At the very beginning, there wasn't even a book about threat modeling. There were a few presentations, maybe a couple of white papers, but Shostak hadn't even published his book. So there was a vacuum of information at that time. Right now, we're on the second Shostak book. I haven't read that one, but there are many authors. Isar Tarandach has joined the bunch, and many others. Brooke Schoenfield, I don't know, the OWASP pasta method. I mean, there are so many methods for threat modeling now that it's a lot easier. But again, sometimes they don't help when you're starting in threat modeling to actually get started and get the results that you're looking for. Sometimes it's just too daunting or too difficult to understand where you're at and what you're missing. And in that sense, and also because on the open source, on the OWASP threat modeling channel on Slack, I was having a conversation with a student from some university, I don't know which one, and she was doing her master's degree, and she was asking, like, are there any open system descriptions that can serve as a threat modeling playground? Are there any known systems or solutions to systems so that we can try in a playground, in a sandbox, to get results? And I think that's a valid discussion to have, and I think that's something that we don't have enough of. There are many talks about what threat modeling is, but there is a lot less on how to actually do it and how does it look like when you're doing it, right? So threat modeling, of all the definitions I have read, the best one I have found is from Brooke Schoenfield, in which he says this is a technique to identify attacks a system must resist and defenses that will bring the system to a desired defensive state. So yes, it's about finding attacks, but actually the value of threat modeling is not in finding the attacks that are possible, but in defining, identifying, and suggesting the best countermeasures to resist these attacks and bring it to the desired security state. Threat modeling, I mean, I'm not going to spend a lot of time on threat modeling itself, but we need to have like a base definition of what it is. And this methodology consists in the widest accepted definition of 4 steps. The first one being modeling the system. And this is one in which I possibly spend most of the time while I'm threat modeling, because I need to understand the system. the developers telling me about their system need to understand all the complexity, all the abstraction layers that they're building, because even sometimes they're not aware of all that they're building and how it could be possibly affected by some things that they oversaw or some things that they oversimplify. Of course, then comes the fun part, which is actually the threat part of threat modeling, figuring out what could go wrong. Once we analyze what could go wrong, we ask ourselves, what can we do about it? And we find a path to fix it. And that in the end, we need to validate the outcome. Is my understanding of the system correct? Are the threats that I think I saw valid? Are the vulnerabilities existent? Did I see something that wasn't there, or was I seeing too little of what was there? And are these mitigations possible, or can we offer alternatives? And in this sense, I think that something that misses in many methods is that they focus too much on the attacks and too little on how they actually happen. And that's why I like the credible attack vector from Brooke Schoenfield as a underlying ground principle, which is basically saying, okay, if you have a threat agent, and you will always have one, bad people, bad entities, bad actors are always there. They need an exploit. They need a methodology. They need some tool. They need some way to abuse an exposed, third item, an exposed vulnerability. So if I have no vulnerability, even though I will always have an active threat agent, I will have no credible attack vector. If I have no exploit available to the threat agent, no vulnerability, even if the vulnerability is exposed, it cannot be attacked. If the vulnerability exists, but is not, for example, internet facing. So a threat agent that is in the internet cannot reach it directly, maybe indirectly, but not directly. So the exploitation depends on exposure and the vulnerability existing. In this sense, if we twist the concept a little bit on the risk management terms, we see that we have assets, we have computer systems, we have databases, we have data, because they provide us some value, but sometimes they also exhibit a vulnerability. Now, if the value is high, or the higher the value, the higher the risk because of the impact, the presence of vulnerabilities increase the risk as well. And based on the policies you have in your company, having a certain risk category for an asset immediately triggers certain policy controls that will try to avoid having this vulnerability, or will try to prevent, detect, or respond to any threat scenario that might happen due to a threat agent. So when someone says threat modeling is doing Stride, I think that's very limiting in the conception and very hard to apply immediately, because you're actually just throwing mud at the wall and seeing if it sticks. It's a lot more efficient if you do the threat modeling, but also identify the vulnerabilities. You can do Stride, you can do Stride all you want, but if you don't have any exposed vulnerabilities or no way to make the exploits in Stride apply to something, you will just be wasting a lot of time. And that's the idea. So who is there using which technique to exploit which open vulnerability, and what do I need to either detect, respond to this occurrence, or prevent this vulnerability or this exposition to the threat agent? If you have any questions, please raise your hands or type directly into the chat. Okay, please. Now, that's it. That's the basis. I will not discuss threat modeling per se anymore. Let's go right into the system. So our target of evaluation is a SaaS platform called Forderly. It's a food ordering system. And this system is or was created at DEFCON 27 by threatmodel.us. And they were using it for a competition called the next threat modeler or something like that. So there, if you go to the website threatmodel.us, you will see the competition. And every year they have a more advanced, more complex system where they patch actually findings from previous years. And that's how it goes. So the system at a very high level is described as a multi-tenant software as a service solution. It provides restaurants, small, medium enterprises, kiosks for their customers ordering, you know, kind of like McDonald's. I think it's perhaps the example that most people might have seen. You go into the store, there's a big screen, you type what you want, just you hit order, it goes, does magic, then you get a prompt to be charged, then you swipe your card, magic happens, and you get an order number, and the kitchen gets a printout. And that's what we have. So we have kiosks for the customers, for the guests. We have printers for the kitchen staff. We have a portal for the restaurant owners or restaurant managers to configure kiosks, to do user management, and everything, of course, in the backend is governed by REST APIs. And it uses a payment processor. Think of something like perhaps Stripe or whichever service you want to make the charges to the credit card. So the SaaS platform is not handling credit card data itself. It's just forwarding the data to a payment processor. And this is one of my pet peeves when I look at diagrams created by developers or by someone, when I come to see a diagram and they try to explain me their architecture. So at a very high level, they say, okay, this is your customer, the kiosk, it talks to a REST API. The printer talks to an API. Oh no, actually the API talks to the printer. I mean, that doesn't really happen, does it? Printers always go fetch and return, right? No entity, no API on the internet will go call your printer inside your NAT network, or not usually. Then we have a admin platform that talks to some API in the background. And we have support people talking to a jump host and accessing everything and anything. And the problem with this diagram is this enough to get started? Probably not. And there's something I like a lot to use, which is the C4 model. And the author of the C4 model, and I'll discuss the C4 model in a second, the author of the C4 model creates these review questions. So if you haven't ever seen them, let me show them for a second. And that's a very good discussion on what makes a good diagram. So first of all, does the diagram have a title? Do you understand what type of diagram it is, the scope of it? Does the diagram have a key or a legend? So if we look at it, we can see that, okay, well, maybe this blue thing means that there is no, that's out of scope and everything else is in scope. But I mean, what else is there? Like, what are the attributes of these systems? And then we have the elements. So are the elements named? Level of abstraction? Do you understand what every element does? Do you understand the shapes, the icons? Now, relationships between things. Does every line have a label describing the intent of that relationship? And I mean, admin, query, print, order, is that it, really? And then we get a detailed diagram. So this is a bit more detailed. Okay, fantastic. So now I have a complex process inside the self-service kiosk, which talks to or is talked to. So this is beautiful. I mean, someone really put a lot of attention, but now this arrow that points upwards is the communication being started here and it is getting there? So is it asynchronous communication, or is it synchronous communication? And this is just TCP over IP. And of course it's bidirectional, but we don't care about the return because we care who starts the flow and who authenticates to whom. Same to this one. And then we have the admin service portal. But if you know how single page applications work, and this is an Angular application, you know that the static files are probably not hosted inside the API. They're hosted in a separate system that serves static files, web, HTML, JavaScript files, images, and there's an API that has the active content. So just by looking at this, we see that it is not consistent with reality. It's not what we would expect to have. And the thing that is missing here is, okay, what is in scope? What is out of scope? Why do we have these data flows? What information is being exchanged over these data flows? How is the information exchanged? How are they authenticating to one another? What level of privilege do they have to run on each interface, right? So to make it easier, I like to use the C4 modeling technique created by Simon Brown again. And C4 stands for 4 times C. Context diagram, which is akin to looking at the map of Europe. Container diagram, which is like looking at the map of Germany and seeing its neighboring countries around it. Component would be like looking at the city, and code could be looking like at the street where a house is laying. And we have all used Google Maps, so there's no need to really drive this a lot farther. The important thing here is, in my experience so far, the first 2 types are always relevant for threat modeling. Component and code, not always. Only when there are important things that you need to check versus what the developers might be telling you. So for example, if they're telling you we're doing input validation and you want to say, okay, show me how you're doing it, they have to open the code, of course, right? So when I try to paint this on or repaint these diagrams, remodel these systems, I try to use GraphViz, which is very easy to use, and I try to follow these basic rules. So everything has to be labeled: the diagram, the elements, the nodes, and the edges, of course. I try to be consistent in the usage of colors. So blue for in scope, gray for out of scope. And I need to understand what every element is and what the connections are for, because that allows me to do in one view the threat model rather than go through 20 pages of the document like the original PDF has, back and forth trying to understand what number 1 or number 7 or number whatever number is that we have here is trying to tell us. So if you look, it's very common that they have like 6 and 8 and 7 and 4 and 5, and sometimes they copy the lines and the number is the same in 2 lines. So it's really, really hard, and especially since they're not sequence diagrams, numbers might be misleading, especially if you have a mixture of sequence diagrams and ID numbers for communication lines. So again, the C4 model, if we want to think of it as the context diagram, so the system with its users and any third-party dependent systems it uses, we zoom in into the container diagram, which is the big individual blocks that might be running. And from there, inside a container, you might have components. And inside one of these components, you have code. And usually the 2 lowest levels, you are able to use tools to create them directly from code. So there's no need to create this by hand. The first ones, you might want to create them by hand. So how do you go about it? So I have created a GitHub repository for this. Give me just 1 second to open it and show it. So this is the URL if you need it. Everyone in the meeting. So I have put in the chat, the window, it's GitHub LF Servin OSS threat modeling for the repo. Oh, I think I didn't push, so give me a second. Yes, now it's pushed. So pardon me, I had forgotten to push. So I have tried to describe the contents of the repository and what you can find. So basically what I do is I create in Visual Studio Code, I create a representation of the diagram. So I have created one for the sake of showing you how easy it is. I will create 2 or 3 items, but I will not create a whole diagram because that takes a lot more time. So there's a couple of plugins. I mentioned them. So for GraphViz, this one from Efanz is the best one I have found because it allows you to do embedded images with everything. So you start by creating a graph. This plugin includes some templates, so you can do very fast analysis, and then you can start creating here your Forderly context diagram, title of the thing, Forderly context diagram, and you're good to go. So if we see it in real time, what we're creating, we'll see that we just have the title. Now I need to create one. So I created a snippet that I have shared as well. And you will see that I have 3 snippets. So I can either create a node as an HTML table that has an embedded icon. I find that visually appealing when you're dealing with technology types, and it gives you in one view what kind of technology it is. Or you can have it plain, HTML node. And if it's in scope, it's the first one, out of scope, the second one. So for example, I could create this one. I could name it kiosk or kiosk. Self-serve kiosk. I have images kiosk PNG, and you will see immediately I have a very nice looking square with a kiosk icon, and it is asking me for some more things. So I tab and I say this is an SE Linux system running an Angular single page application. All right. And that's it. I have created successfully, and description of purpose, of course. Allows guests to order, pay, and provide feedback. Of course, it's pardon, I made a mistake. Fat finger that way. So very easy. I will not create the whole thing. I just want to show how it is done, and I find it's very easy to create these diagrams live while someone is describing the system and while we're looking at the other diagrams, because it allows us to have a description about the purpose of each element in the diagram and the characteristics they have. So is it using certificates? Is it using this? Is it using that? How is it accessing the backend? What kind of credentials is it using? And here we could have the API, right? So let me create another one. So this will be my API, or I will call it, rather than API, order API, order API, and this is in images, an API PNG, and this is a Java web service. Java application which handles orders, right? And then how do you join them? I usually do something like this, which is then very, very easy to follow, which is basically kiosk talks to order API. And I enhance the communication by saying, okay, this is calls API functions, and it does it over HTTPS, and it uses X509 certificates for authentication. So this is how I usually create the diagrams. I know there are alternatives for this. I know there are very nice GUI things that you can pull and connect and do things. I find they are a distraction, personally, for me at least, because that usually means I have to break from my workflow, or if I want to keep these diagrams up to date, and I create them in this repository under the /docs directory, then the code, then developers need to break out of their workflow to update the diagram, which means they never update the diagram because it's in Lucidchart or it's in Visio or it's somewhere else. And it often happens that someone leaves the company and takes away the original. So every change to the document means redrawing the whole thing. Whereas if you keep it in code, you can even create the updated diagrams on the CI pipeline by using GraphViz. And why do I do this? Because I can start creating a report. Sorry, here's the report. How do I unpin the top part? I cannot see my screen because of the. So this is how I usually start creating the report. So I start saying, okay, I have my target of evaluation. I make a very brief description, maybe even copy paste it from the original one. And then I have the context diagram. I embed the context diagram in it. And then I embed the container diagram. So I went from having this diagram to having this one. Now, by looking at this one, I can immediately come up with at least 4 or 5 vulnerabilities without having to scroll through 10 pages of documentation or 20 pages of documentation. And in that sense, I would like to open now the forum for everyone in the call to help me here. Okay, so again, is this good enough to be seen? Can anyone raise your thumbs or put them down? Is this readable, or should I zoom in a little bit more? I see thumbs up. Okay, fantastic. So my self-serve kiosk allows customer to browse menu, order, and pay. Phones home for fetching updates and configuration updates. And I immediately, because of my background as an automotive employee or an employee of an automotive company, as soon as I see this update thing, bells start ringing. Why? Because that's an immediate threat. How do I know that the binary that I'm receiving is authentic, original, and comes from a trusted source? Anyone would like to perhaps open their mics or chat into the window? Oh, you can only post direct messages. I can read it. So signatures. Daniel says signatures. You cannot unmute yourself. So Katie, is it possible to open the chat to make it less restrictive for participants to unmute themselves?
Yeah,
Or...
I should just have a look and do that. Bear with me.
Sure.
You should now be able to unmute yourself. I will have to be very quick off the mark, so everyone behave themselves, please.
Okay, let's hope everyone behaves. So I think Galina wanted to say something. Galina,
Yeah,
are you there?
well, first, hi, Luis. Thank you very much for presenting. It's a very interesting topic. Sorry, I'm a little bit sick, so I will be quiet today. But I definitely want to work with you on brainstorming on these ideas. Yeah, I wanted to say that, yeah, we see it perfectly. The diagram is good. Yeah, I just want to engage other participants to start. And if we don't have other activities, I'll talk more. Okay.
All right, fantastic. So
Thank
anyone
you.
that would like to join in, I mean, we have here a self-serve kiosk. We know that it sends order and payment information, credit card data. It retrieves and updates config changes, and it has an HTTPS certificate. Is there anything here that inspires you to be especially careful? And this is usually the point where the threat modeling starts, right? So we have the modeling behind us, and we start with the threats. And sometimes the point here for people starting into threat modeling is, I don't know where to start. So I'm looking at things, I have the feeling that something is not great, but where do I start? And one thing that I have found across all the systems that I have analyzed, across all the domains, is principles, technologies change, principles do not change. And there are two lists of security principles I usually refer to. The first one is from 1975, so older than perhaps most people in this conversation today. From Salzer and Schroeder. So these are very old principles that are still valid today. And they said, okay, economy of mechanism, also known as keep it simple. Fail-safe default, fail close rather than open, do not accept all connections by default, do not accept any connections and then open little by little. That could be the fail-safe defaults, for example. Complete mediation, which means authorize everything. Don't allow access to anything if it is not authorized. Some entity has to authorize any request. Open design, the key is the secret, not the mechanism. Separation of privilege, if it's necessary to make a request and someone has to approve it, it shouldn't be the same person, for example. Least privilege for humans and machines. No one should ever operate with more privilege than they need. Least common mechanism, for example, environment variables. Try to avoid using environment variables for sharing secrets because they are available to anyone. And psychological acceptability. And this is something that security practitioners tend to forget. And we place a burden on our users that they go out of the way to go around any security controls that we define. So when we look at this and we consider this option and we think, okay, can I apply anything of this to the diagram that we were just seeing? So can I identify any vulnerabilities? I find it a lot easier to identify vulnerabilities and then start attacking them, rather than start with a bunch of attacks and see whether something sticks. So the second method, I call it taking a moth in your hands and throwing it to a house and see whether some mothballs stick to the wall. It's not efficient. It wastes a lot of time. And if you have a methodology that works, it is a lot easier to find several attack vectors to one vulnerability rather than the other way around. So let's think about this. So again, concentrating on this first one. We're talking about certificates. And we know that the certificates, because of the file, of the documentation, we know the certificates are created, are embedded in the machines during creation time. And every time there is a certificate, we should ask ourselves one question. What is the PKI, the public key infrastructure generating these certificates? What's the validity of these certificates? How do you renovate these certificates? How do you handle the lifetime of these certificates? How do you revocate these certificates? So the first finding here would be, where is the PKI? Right? I mean, we don't have to be incredibly technical to start with this. Where is the PKI? So we could go back to our report and start writing. We could start writing directly vulnerabilities. We can start in a more in a scenario that has more stages. So we could have, okay, of course I wrote starting from other places. I started with a printer, of course, which is the easiest path, but basically we could just write it here as well. So here I could say, okay, 0, because so the title is PKI defective, insufficient. I don't know. There's many ways to describe it. Of course, I'm doing it very fast. What is the vulnerability? So this is the point where it gets tricky, right? So what is the vulnerability with not having a well-defined PKI? So the vulnerability is the life cycle of the certificates
Is not clearly defined.
Is not clearly defined, exactly.
And the threat would be because it's not clearly defined, right? The attacker potentially might explore this vulnerability, right, and gain access to our kiosk or orders or payment mechanism.
Yes, and this is a place, I'm not sure if you have had this experience yourselves, but you usually see yourself in the necessity of selling. And when I was giving threat modeling classes, I always talk about this. You have to sell your findings to your customers. Who is your customer? Project managers, developers, their bosses who are not technical people. So you need to convey the message, not necessarily about whether you can spoof it or not, but how it happens and what is the outcome for the business, right? And for that, I like to use BDD, behavior-driven development, the concept behind it, which starts with given, when, then, which means given this scenario, this vulnerability exists, this scenario, when this happens, then this is the outcome. And that gives you a very structured way to present your findings that allows your customers, especially if they're developers, to follow through and allows you then to sell the outcome. So what could be the outcome? I don't know, we could discuss that right away. So let's write this one. Given we don't have a well-defined PKI with a CRL serving point, when a certificate is extracted from a kiosk. Now remember, these kiosks are in the hands of the enemy, right? They're in the hands of people that they have them, and they can take them apart. They can try to connect to them. We have no idea what the characteristics are of these kiosks, right? So given we don't have a well-defined serving point, and we can even add a certain precondition, and we have no.
Even add, I think if you sorry to interrupt. If you want interactions from me. So you can even add that it might even be like some self-signed certificate, right? That never expired and never have any certificate authorities in place. So it's even easier to actually tamper it with than sniff on network or sniff on this HTTPS connection, right?
I'm not sure you can sniff on it per se, even if it's self-signed. Because the endpoint would need to know about it, right? So if they're authenticating with the endpoint and that's the authentication
But
they
you
use
you
with
can
the
definitely
endpoint.
try to impersonate it if it's self-signed without certificate authorities, right?
I mean, it depends if the end device has some kind of certificate pinning. If it just sticks to this one certificate, it would be okay. But if it's not, then yeah, you have a problem.
Well, that's the kiosk, right? But then the API. So the API is authenticating and authorizing the kiosk based on the certificate presented.
Ah, okay. So like mutual TLS.
Well, but we don't have that, right? So we know we have mutual TLS down on this side here. So we know we have mutual TLS right here.
Ah, okay.
But we don't have mutual TLS here. It's just HTTPS. And the
Do you
certificate,
know what type of TLS we have? If it's like higher than 1.2?
it's 1.2.
Okay.
I mean, at least that much, but I mean, it's not a lot, right? So again, this is just one example, and from this vulnerability, and that's the advantage of looking for vulnerabilities. Once you have one, you can start pinning on that one to create different attack scenarios, right? So we don't have a well-defined PKI. So one is the certificate is stolen, is extracted from the kiosk because we don't have any HSM storing the certificate keys. No hardware security module or TPM, HSM / TPM, if you want, or whatever other secure storage means. Then an adversary can impersonate a kiosk and create orders for a customer. The outcome being for us as the providers of the SaaS service, not the restaurant, the outcome being perhaps over and there are perhaps several things here that could go wrong. So we could grant access to unauthorized parties. We could also be creating too many orders for a customer, too many, and here we can decorate that with non-existing orders for a customer, and so on and so forth. And the priority of this one is perhaps not that great. I mean, medium, it takes a lot of effort to take the certificates out of the kiosk, right? Now, if we pivot on this one, and we can just copy that one here. I'm not sure if that's readable. So here we had the, oh God, what did I break? Did I break the table? No, there's a table. Okay. So here we have the table, we have the attack scenario. And I create them in Markdown because then it's easy to have them in text, and they look nice when you can even print this as the report, right? And of course, we can even add to this one security countermeasures. And then we can decide, okay, if we copy some of this, we could try out the second attack scenario that Galina was describing, right? So we have here 0.5, 0.1, PKI defective, or we could say impersonation of kiosk, and we don't care about that much. The life certificate is not clearly defined. The vulnerability is the usage of a self-signed certificate with no clear cert authority. Given we don't have a, I could even call it, I could even leave it like that. And then the attack here is when an adversary creates a self-signed certificate, then we grant access to our admin and order APIs. And we haven't even discussed Stride, right? So this is not spoofing, tampering. Again, I find it a little bit easier if you start with looking for vulnerabilities and then start thinking of the attacks. I think it flows better when you're into it. So again, if we want to look at into the details here, that was just one aspect of it, right? Now, we could identify the printer and see that the printer connects over HTTP and provides a GUID as the identifying vector to the SaaS system. And we immediately jump at HTTP, right? Because we can spoof it, we can tamper with it, we can intercept it. There's so many attacks we can do to it. But the second thing here is interesting. Anyone knows what a GUID is?
A more or less randomly generated ID.
A more or less randomly generated ID. And how more or how less is it? Should I be using it as an identifier of any sort?
And actually depends which kind of function is used to create it, I think. But
yeah,
more or less.
I was thinking of that. Go on, Galina.
What library are you using to create those random IDs, right? Because they might not be random at all.
Well, do you know what's the best thing about this? Is that there's even an RFC for that, 4122. And like all RFCs, they usually have something for security. So I just went and took a look at security considerations, and they just tell you, hey, do not assume that these very long, apparently very random numbers are hard to guess. Never use them as identifiers. Predicted random number will exacerbate the situation. So basically,
amazing.
It's a terrible idea. Don't do it. I mean, if the RFC tells you don't do it, you don't do it, right? So that's one thing. So basically, this is horrendous because when we look at the next level diagram, we can see that the printer interacts with the order API, which is the same order API that the self-serve kiosk was interacting with.
Sorry to interrupt, Louis.
Pardon?
Sorry to interrupt. So with respect to this GUID, I agree that whatever the recommendations are, but GUIDs will be generally generated with the kind of MAC ID combination or date kind of, I mean, too difficult to guess, right? Isn't it? I mean, that's my understanding.
They're difficult to repeat under normal conditions. They're not necessarily difficult to guess, especially if the API is open and has no rate limiting.
Okay.
And works as an oracle, right? Basically, if you send the wrong thing, it will send you back an error message, and you can keep on trying until you get a positive message.
Okay, understood.
Right. So right there we have one more vulnerability.
Okay.
So because this one is HTTP and is using a GUID, and this one is HTTPS. So if you have ever tried to host something, you will realize everything is then available on HTTPS or in HTTP. So you can find the whole API both hosted at port 80 and port 443. It's not like you can really host different functions of the same API in different ports, right? You host the whole thing. At least when I have found anything on port 8, it's usually a copy of whatever there is on port 443 because it's the same system, the same bunch of functions being exposed, which means anyone could be calling any function of the order API. So it's not just the printer that is hit with this, it's that the order API could be hit as well. Now, the self-serve kiosk is also accessing the admin API for looking for updates. Now, does it make sense from a separation of privilege to have the same API being used by humans and by machines, especially if the machine is using it for updating config changes and other things? Or should there be perhaps a separate API for machines? That's more an architectural decision, of course, but then binaries. If we have binaries being served, are we signing the binaries? How are we signing the binaries? How do we know about the authenticity of the binary? How do we know that it was not intercepted? I mean, we already discussed certificate pinning as a mechanism. Because again, the kiosk is running inside a network outside of my control as forderly, right? So anything in this network, and they are using Wi-Fi and DHCP. So basically any DHCP server could be controlling also DNS name resolution and sending the kiosks over a path of their choosing to access these things. So if I have no certificate pinning, I would be unable to access it, to be sure of what I'm doing, right? There's another beauty here, right here in the center. Anyone notices something strange or something that we shouldn't be doing in 2023 with the admin API or the order API? Perhaps the last line of each.
Yeah, it's a very bad idea.
Storing credentials in plain
Especially,
text,
yeah,
says Ola.
if you're sending it via GET, what methods they using to send it?
Come again, I couldn't understand you, sorry.
Sorry, I'm just sick, like I'm very contested. What methods they're using to send it, especially if they're using GET?
Well,
Those
yes,
say
of course,
API.
they might be using GET. That's one thing. On the other hand, it's the credentials to the database, right? So we can see here they're using JDBC for accessing the database, and on this side they're using TCP over naked TCP over IP with a custom cipher and sending admin and password. And then what we see here is they're both logging in as admin and password. So
Okay, so least privilege and authorization mechanism is missing.
So first of all, we cannot tell one from the other. So if we start seeing on the database logs that some admin is writing like crazy or deleting tables, schemas, customer tenant IDs,
Yeah,
we have no idea who is doing it.
your auditing is suffering here.
Yes, so that's one, right? We have no idea. Second, why are they accessing as admin? Least privilege, right? Order should only be able to write into this table, read from that table, and be done with it. For example, it has no business writing into the tenant table. So if I, as forderly SaaS, have 100 tenants, my order API should not be creating the 101st tenant or deleting all 100 tenants. That would be catastrophic, right? Same goes for the admin API, where humans are actually interacting and typing code. So I don't want this admin API running queries to the database with elevated access rights. I don't want them to drop the database. On the other hand, hard-coded credentials to the database inside the code means every developer with access to the code has access to the credentials. And the order API has the credentials as plain text stored in a config file. And nowadays, we should be using a key vault, right? So there's no need to keep credentials in clear text anywhere where humans might get in contact with them. And the same situation we find here with ops. So we have a group of people doing operations management, which connect to the rest of the network through a jump host, and this jump host uses SSH, and they connect as the support user with an SSH key. What two problems do we see here?
Sorry, Luis, can you come again, please?
No unique identifier of users. Yes, Ola, you got it right. So every single user of this group is connecting as the support user. So they are sharing credentials. And the second one is they're using one single SSH key. Now, if this SSH, even if they were using individual users, what happens when one of them leaves the company? How do you rotate the key?
Installed SSH keys, they're not expired unless you do it manually. So you don't have auditing, you don't have authorization, and your authentication is definitely like not least privilege.
Exactly. So those are a few inputs or a few attack vectors that could come out of it. And if you're not using certificates tied to the SSH key, you cannot have a certificate revocation list. Now, the SSH server could go fetch from the certificate revocation list, see if the certificate key is being presented is still valid, and grant or deny access. So I cannot tie it to the HR processes I have, for example. And on the other hand, this beauty has all credentials to all other servers in plain text inside, or I don't know, some path inside the support user account. So game over, right? As soon as someone gains access to this jump server, it's game over. They have access to the whole infrastructure. And it's, of course, open to the whole internet on port 22. So I don't know, do they need it all the time? Could it be a Bastion host? I mean, we don't even know if it is running in the cloud. Galina, you wanted to add something? No, okay.
Not for now, sorry.
All right. So there's the last one before we close the call. Oh, we're already in time, so maybe we don't have the time to make it that interactive. So this payment service is receiving HTTP unauthenticated from the order API, and it's sending credit card data through this path. So basically, again, being unauthenticated, it could be sniffed, it could be tampered with, it could lead to a lot of potential disaster for every single guest of every single one of our customers, right? Because this is a shared tenant ID. And I mean, there's so much to get from this one. So I have created a list of, so I have this report with some cases just to give you a starting point if you want to look at the repository. And I also have a brain dump of findings, which I will commit right away, which is basically based on the description. I have made a list of all the findings I could come up with in as short time as I could, because the idea was to make this workshop a bit more interactive. So I hope this helps you a little bit. We could repeat this in an upcoming Open Security Summit meeting. If anyone has a system that they would like to analyze or have some help analyzing, we could do this together. I offer my help, or we could prepare it beforehand and then present it again in some interactive way during the Open Security Summit. And in that sense, I will make everything available right away, and you can play with it and the slides will also be made available through the Open Security Summit. So thank you very much for your time.
Thank you very much. Thank you very much. It was fun. When the Open Security Summit happens?
It's right now on. So it's every, help me, Dennis, it's every
It's
6
every
weeks?
2 months.
Every 2 months.
Every 2
Okay.
months. The next one will be in April. So if you keep an eye on the websites, that will be updated soon. Okay.
Okay, perfect. Thank you very much.
Brilliant. Thank
Thank
you.
you for the
Lewis.
content. This was interesting.
And thank you, Lewis. This is Nick. I'm from the DEF CON's Next Top Threat Model team. Thank you for using our design. I think all of the findings that you referenced here were things that we put in intentionally. I'm really glad that you and others are able to use this. We're planning to post this publicly soon. We just haven't gotten to this in a while. So
Yeah, thank you for reaching out and sending me this simple system that is a great playground for starting into threat modeling, right? I think it's a fantastic opportunity to learn how to threat model.
yeah, we've responded to DEF CON's call for contests, so we haven't gotten approval yet. That call's still open. So once we know if we're been accepted again for DEF CON 31, we'll put that out on our website and on Twitter as well. So.
Fantastic.
Brilliant. Thank you very much, everyone, for coming.
Thank you, Lewis.